Welcome again to Wickerson Studios. I am going into the Rhino developer site, and here's where I've grabbed the script. It's pretty simple. Steve Bears put it together. Fairly simple, adding arrowheads to curves. So not too much to have as a function that you can cut and paste into. You can grab the whole thing, and you can run it as a function in going into your Rhino window, and I'd have to go into Tools and Python Script, Edit, and I would want to start a new one. Actually, that's it right there. And basically run it there and see if it would work. And it does. So that leave that out, and then go into your Grasshopper, go right to the red in the script that I have on GitHub for everybody. Double click on that script. I should have all of my actually, I don't have these set to list. I have them set to individual items as they come out because they're making points. So you just have to be careful of what you set your access as. And even though you have a list coming in, you sometimes want to set that to a list to an item access. And then my type hints are all integers for here because I wanted to have some spacing between the arrows. And you'll see this little machine work. It's pretty simple, and I could have brought the maths more in to the actual script. As opposed to doing this all in Grasshopper, but if you know me, I really like the helix approach to creating forms with sine and cosine and the x and the y and z, and I threw a little pipe in there, which is kind of fun. And what this script basically generates are the attributes. It's just a series of Rhino doc objects, depending on how many there are. And then a line is generated, and that line's temporary, and well, those lines are temporary, and I think they actually are producing several lines, 11 at a time, because that's my step count. So I could lower that if I wanted to, and I probably have one double that I should probably go in here and ensure that, we've got 10 items there, and we've got 11 here and 11 here. So just good practice. Go into your go into here and change your, why am I not able to on a Python script? Probably not. I'll have to do it here external, which is interesting. We're going to minus this one just to have it be 11 items. And we're going to do the same thing here. It just takes a second to load when you have your script running. It's hard to just grab another node. And there it is. And we're going to grab this value. And then we're going to grab a 1. Now we're just going to minus 1 from there, 1 from there. And that should allow us to make the exact amount of points we want. 11 values from source. Oh, I'm such a fool. No, I've got to take this in, and I've got to do, I've lost my mind. I don't know why I've lost my mind. Why am I doing this? Once I start playing around, I'm going to show you how I made this mistake, because some people might make it. I don't need that there. I need my list count to come down and be one less than this number, 10, which I want to bring into my steps. And this one I want to bring into my steps. So I want to minus 1 from there and 1 from there. And I guess I could use the same thing there. So I was just getting ahead of myself, just bringing my count down, and obviously 1 is the number that is bringing it down in count, and now, with any luck, I should be down to 10 count, 10 count. So I was making mistakes there because my head was out of sorts, but that's fine. How the script actually works is I've cut and pasted it. You generate a line, and you create that from Rhino geometry. Line from 2 points at Rhino geometry 3.3D, and I have that set to 0, and obviously it's parametric to the XYZ. And you're going to have as much fun with that as you want to begin with. Then I'm making a copy of the Rhino's default object attributes, which is something I've never done, which you have to go into. Also changing from what it was script context doc. You want to change it to this, and I'm going to keep this kind of highlighted here up front because I'm using it quite often. Otherwise, I'm not baking it into the Rhino window without Rhino doc, active doc. It'll find the one that I'm active and bake that in. I guess that means it doesn't, it bakes into all of them. Kind of interesting, and actually I think I'm going to actually view this, since I haven't been doing that, like this. And you'll see how this script runs. Any iteration is going to pop up. And then you modify it by the decoration style, which puts a little arrow at the end of it, both arrowheads, which means both sides. So that's a cool little attributes object decoration method or function there. And then you're going to create a new curve object with our attributes. So Rhino doc, that's where I had to change the script syntax and add a line with the attributes on it, the attributes being those wonderful arrowheads. And then I want to redraw it into the window. So how this script works is you can get rid of all the stuff you've made because it's going to bake in each time. And whatever I decide to do, so if I grab this and edit this down to, bring it down to 0 to start, bring this one zip down to 0 to start. And the reason I'm doing this is I don't want to actually see the line get baked, even though it is getting baked. And this is very playful. I'm just having fun with this. So my initial line when I run it is there. But what's nice is I will see what happens as I use these sliders. So if I pull X out, it's just going to produce this over top of itself longer, and keep the last line. So that's really all it did, was just kept that last line. And what's nice, so you start to throw that through some rotations in the Y's, and now I've just affected the Y's up to 10, which is not doing anything yet, and there it is exploding off into the Z. And now I can start to play with where I'm pointing those at any time I want, and it grabs the final geometry on what's selected. And I've got a pretty interesting thing happening here that's kind of losing out on the artistic mode. Maybe it'd be best to go shaded. There you see all the points being generated as I'm rolling that through. And of course, X is the main factor of what's being influenced by sine and cosine. So I can bake more than one, produce these interesting little GIF geometries, and have kind of this history of recorded vectors with it. Well, not just vectors, so these lines with arrows at both sides to generate what I'm doing. So 5, 10, and 10 is like that. I can generate a little bit off at 7. If you started dealing with floats, this is going to get pretty complex. And I used kind of like a strange conceptual optical clock. So kind of a nonsensical little thing. But the reason I'm doing these exercises is it's nobody else's exercise. It's definitely taking from the scripts that Steve Bear has put together, trying to bring them in and be playful with them as how they work within Grasshopper, and then activate them as kind of these strange scripts. They are pretty pointless, but the tool sets and the creative thought that's involved in them hopefully will put me in another place. And it literally is like a painter playing around with paint for the first time, and ceramic artist or somebody dealing in plaster or clay or wax, and trying to figure out what these things can do. So I'm just going to basically go through all of these wonderful scripts, the ones I can, without getting too bogged down. Because when I get in here and I go to, say, add a background bitmap, I probably would default to like nodes that have already been scripted and coded to make bitmaps at their origin. And I see a pretty complex script here that if I break it down, and of course I'm seeing a script difficult one here because I'm in C, but if I break it down, I start seeing these new systems window forms dialog requests. I start seeing these FD, basically the filter going through these files, and then I've got these conditionals that I'm basically getting out because I don't mind taking the conditionals out when I move it into the Ghpython node. I try and get it down to the last thing I have. I'm getting into some get functions, constraints to construction plane, but in the end it does look very reminiscent here of what I was doing earlier, this sense of a plane through an active viewport, and then simply bringing that object into there. I think I did that earlier in a couple of files ago. And then you can run it as a function, but I'm not going to do it. I'm going to take out the bare bones of this. I probably, in all reality, will leave that one. It seems more advanced than what I want to do. And if I went into something like this, it's much easier to get in here and get this add breadbox going and make it parametric and make some art out of it. And I've done that before, but I think what I'll do is take these single scripts, get to use them more, have them as my own little nodes, private clusters in Ghpython, and start to use them as geometries. And once I build up an inventory of these, of 20, a couple dozen, 3 dozen, then I should be able to handle some cool geometries that are driven by Ghpython nodes. I hope you're finding this as exciting as I am. It's like I said, it's a little dry, but without going through this and getting these things ingrained in your head, you might be looking for answers on Rhino script context, which are functions others have made. So you're going to have limited creativity when you do that, and it really does explode into a sense of questioning what exactly you're doing when you're doing this philosophically. To me, I feel like I'm pushing this on an artistic front that nobody else is really doing. I mean, there's other ones that have creative coding, does pretty incredible things, but I haven't seen it laid out as dead clear is basically get in there, get your Rhino window open, get your Grasshopper open, play. And I haven't even played with the amplification, which is just the final thing. If I was going to amplify this over in another area, I can do that. But um, just having fun with it. And then if you don't like what you've baked, it's just like I like this kind of recorded history of the arrows, which I hadn't played with before, and it's kind of fun. And then you can kind of delete ones that you don't like, and you didn't want to go that side. Um, yeah, it's a little toy. That's basically what it is. And I always test these toys in front of my kids because they're young, 8, 10, 4, and if they find it interesting and playful, and they want to get in, maybe script in here, like say you didn't want, maybe you wanted the next set in a uh, well, just throw on a negative y. Just throw that in nice and simple, add the test, and start rolling that one around. That's not going to matter too much because it's sine, cosine, but what if I threw that negative x into in the x direction? That's going to do a little more than the y. So you start to think of things geometrically, and now I'm around the backside now, having symmetry and fun with what I was doing and generating this over here. So yeah, it's a little weird box, kind of containing itself and being playful and just picking and choosing what I want and baking forms and lines that I maybe could use for other geometries. And the real question is like, what is the purpose of this? Like, where does this information come from? Why are these sliders being slid in this way? Why are these numbers being chosen? Well, that's where you can apply this. And to me, this is a simple, not simple, it's a complex data visualization tool, which is as as complex and conceptual and intricate and creative as oil paint on canvas can be, or gesso or stucco on plaster walls has been in the past, or finger marks on wet clay walls in Lusco, or Le Trois Frères, and all these. Like, I'm no different. It's just these are the tools and these are the hands that are doing it. Um, Welcome to it. I hope you enjoy it. I hope we keep garnering interest. But if not, I'll just do it on my own. Thanks for watching.